So the difference between a rational versus an irrational square root, the rational square root is a result of the square root of a perfect square. So it's the square root of a perfect square. And perfect squares are on your exponent quiz in the first hand column. They are the values that you wrote in. So you wrote in 1, and then you wrote in 4, and then you wrote in 9, and then 16, and then 25. These are all perfect squares. An irrational square root is the square root of a non-perfect square. Square root of a non-perfect square. So we're going to get to some examples here. So we're going to determine whether our answer is going to be rational or irrational. So our first example is the square root of 100. So is that a square root of a perfect square, or is it a square root of a non-perfect square? We're looking at the radicand. Is the radicand a perfect square? It indeed is. This is equal to 10. Therefore, this is a rational value. Irrational numbers are numbers that are decimals that are infinite without a pattern. Irrational numbers come from also those square roots that are non-perfect squares. So here's an example of one of those, the square root of 10. Well, 10 is irrational. The square root of 10 is irrational. And the reason the square root of 10 is irrational is because 10 is not a perfect square. So this is not, I just say not perfect. So it's not perfect. Therefore, the square root of 10 is irrational. Okay, I'm going to do one more. I liked that last one, how we did groups of 3 to begin with. Plus or minus the square root of 0.36. Remember, it's all about the radicand. Is there anything times itself that is 0.36? Well, sure. You're going to get a plus or minus, but 0.6 times itself is 0.36. Therefore, the square root of 0.36 is rational. Okay, let's do a couple of tries. So our try is the square root of 8 plus or minus the square root of 225 and negative square root of 75. So go ahead and try those and see what you get. And then take a look at the answer. So press pause if you're still writing and doing. Okay, the square root of 8 is irrational because 8 is not perfect. So it's not a perfect square, therefore we have an irrational value when that imperfect or not perfect number is the radicand. 225, I believe that is on our exponent quiz. So our answer here is plus or minus 15. Therefore, the square root of 225 is rational. And the negative square root of 75 is irrational. Let's try two more examples. We've got 4 over 169, and all of that is in the radical, so all of it is the radicand. The square root of 4 is 2, and the square root of 169 is 13. So the square root of 4 over 169 is equal to 2 over 13. That is rational. The square root of 1/7. Well, the square root of 1/7, 7 is not perfect. And when that happens, and the radicand has an imperfect number, one that is not a perfect square, you're going to end up with an irrational value. So if I put that into my calculator, I'm going to get decimals that repeat with no pattern whatsoever. Now I know it says 2 tries, but we really only have one. The square root of 1 over 20. Is that rational or irrational? If you said irrational, you would be correct. So I'm going to end this video right here because I really want to talk about between what two consecutive integers, an irrational number under an irrational number with respect to square roots, where that lies. So between what two integers would that irrational number fall? So we're going to take a video to do that so that we're still dealing with some smaller language.